Okay, hopefully this video will help you out with a particular question in the packet that a lot of people are having confusions on. Understandable. Question 4 definitely has an extension that we haven't talked about yet. Just to give you an overview, I wanted to sort of talk through why a lot of these questions might look different than what we've done this chapter. In chapter 7, we've been focusing on techniques of anti-differentiation, finding that antiderivative. So in order to, if we go back to concept from chapter 6, we've talked a lot about these definite integrals where we have two limits of integration. We have fundamental theorem of calculus. It tells me that if I have an integral of some function evaluated from a lower to an upper limit, I can take the antiderivative, evaluate at b, antiderivative, evaluate at a, and subtract the two, and that gives me my answer. So in chapter 7, we've gone into the mode of talking about what we call indefinite integrals, where instead of my answer being a number, when I subtract these two numbers, I get a number that represents the area under the curve between these two values of this function. My answer is now a general function, and I'm not evaluating between 2 points. So we've been leaving off these limits. Why? Because I didn't want to spend a ton of time just plugging numbers in. That part's easy. Once you get the antiderivative, you're just plugging in two numbers and subtracting. So it's just extra time. So in this packet, you'll find a lot of the techniques we've been working on in chapter 7, things like u-substitution, reversing our derivative rules, things like inverse trig, logs and exponentials. All of those should be in there. But you will maybe have to go that extra step and go ahead and evaluate the antiderivative at two values, subtract the two. Okay? Question 4 requires an extension beyond that. So let's take a look at this. I noticed that we've got this defined integral here, and that's really the only number we have since this is a general question about some f of u. We're not going to have a specific antiderivative rule we can use. So I'm going to have to reference this at some point. So my goal is going to be to make this look as much like this as I possibly can. So I'm looking at the integrand, and I've got it in terms of u, f of u du, and this is in terms of x. So my first goal is going to be, let's try to make it in terms of u. So that's leading me to say, if I can define, I want this to be f of u, so I'm going to actually make this be my u right here. So I'm going to go over here, just have some space to work, and make my u be x squared minus 1. And then let's go through with what we normally do. Du dx would be 2x, and then your choice, but most people have been solving for dx, so du over 2x is dx. And if I do that and then go over here and make this a u and rewrite, I'm going to have integral of, I still have an x out front, f of u. So here's my u right here, f of u. And then my dx, remember, is going to be this du over 2x. So times du over 2x. And then we're going to go through with what we normally do, and we're going to cancel this x with this x. I'm going to notice this extra 2, but that's really a 1/2 out front, and I'm going to actually pull that out, so I've got 1/2. And then I really have the integral of 1/2, or 1/2 times the integral of f of u du. And it's looking pretty good with what I have over here. The only thing I don't have is I don't have these limits of integration. And you might have noticed that those numbers don't match these numbers, and that's kind of weird. Like, what am I going to do with the 1 to 3 and 0 to 8? So the problem is that this, if I put a 1 and a 3 right here, that would not be considered correct notation, because I now have the entire integrand in terms of u, but remember, these are x values, because it started out that it was in terms of x. So what I actually need to do is redefine those values in terms of u in order to have correct notation. Normally, we don't do that, because we evaluate the antiderivative, we put it back in terms of x, and then I plug in numbers. And if I do that, I really don't have to worry about it. Technically, if I write the 1 and 3, it's wrong. But if I go through and substitute the x back in and evaluate it at those x values, I'm never going to be wrong. So usually I just keep the limits the same. But if I'm trying to answer sort of an abstract question and not actually plugging numbers into some known antiderivative or antiderivative I can figure out, then I'm going to have to do this extra step. So what I'm going to do is I'm going to go ahead and take my equation that I have right here, but I'm going to solve it at two values. So I want to figure out what is u when my x value is 1 and 3. So for my upper limit, u equals 3 squared minus 1, which would be 9 minus 1, which is an 8 for my upper limit. And for my lower limit, u is going to be, again, I'm putting in my u right here, but my lower limit is a 1, so 1 squared minus 1, which is actually a 0. Now you're looking at it and saying, oh, I get it. That's where the 0 and 8 comes from, this 1 and 3. So now that I'm looking at that rewritten, completely rewritten integral, hopefully we're seeing that this right here is exactly what I have right here. And therefore, I know that that is equal to 6. That's what they've defined for me. So the math that you're doing from here, obviously very easy, because I figured out that that's 6. So my answer is 1/2 times 6, giving me 3 for what the integral is that they've defined. It's really 1/2 times the integral they've already told me is equal to 6. So final answer there would be B3. Hopefully that helps. That's sort of the most abstract one. Another question that is sort of similar would be question 8 in your packet. And I would advise that you make a u-substitution there also, where you have f of 2x dx. Try to rewrite that as some f of u du and see what you can do with that. And remember to either convert back to x's, or you can convert the limits of integration in terms of, and put them in terms of u. Okay? Hopefully that helps. Let me know if you have other review questions.